There are two things that a scanner is designed around. One is the barcode, and the second around the technology that is available at the time. Technology available at the time was a helium neon laser, which looks roughly like that. Helium neon laser is a product that produces a beam of light which can be focused to a very sharp point, and that in turn can scan across a barcode as a very small spot, and the small spot, as it scans across a white bar, reflects red light back to the scanner, and when it hits a black bar, no light goes back to the scanner. So as this moves across a bar very quickly, then you get a series of bright and dark levels. The bright and dark levels are then converted from an analog signal to a digital signal as ones and zeros, basically. And the universal product code was controlled by U.P.C, and they came up, which is Uniform Code Council. They came up with specifications on both the location of them on a product, as well as specification on what the barcode has to look like. And there are a whole number of variants of barcodes that Frank may mention, some of them, including the standard U.P.C code, as well as EAN systems, etc. Then once this red beam of light hits the barcode, then light reflects off of the barcode in all different directions, and some of it's collected by a lens inside the scanner. And from the lens, that's focused onto a photodetector. This is an example of a photodetector that was used back in the early days at a time. This is an avalanche photodiode. Avalanche photodiode has a bias voltage put on it, which puts it at a critical point to where a minor amount of current flowing through the photodiode portion of it causes a cascade of electrons from each photon that hits the detector. And then from there, it's of course amplified and then decoded. There were a number of different ways of decoding, converting from analog to digital, that were used at that time, including ones that used the first and second derivative of the signal coming back. The first derivative, of course, shows the slope of going from a black bar to a white bar, and the second derivative of that, right at the inflection point, is the point at which it changes from a black to a white bar. It's the point of maximum slope from black to white level. Then once the signal's converted to a digital signal, then Frank Check will discuss about the decode algorithms for that. As far as other things that happened related to scanner design at the time, after the creation of the bar XX scanner, which was able to read barcodes at a very wide range of angles on products, there were issues related to ergonomics that came up. For example, if you could scan products as quickly as possible, does that mean you should scan them quickly as possible? Or will you induce various injuries by trying to scan too fast? In the early days, in our naive days, faster and higher production was always better. It was found that that was not always the case, that scanning slower was more ergonomic, and scanning in a more neutral hand position was more ergonomic, just as in the same sense that typewriter keyboards was designed intentionally awkward to slow people down, to cause them to type slower for an ulterior reason. Scanners were designed to have a more ergonomic movement. And one of the things that came out of that was if the barcode is passed in front of a side window, then you don't have to lift the product over a window that might have glass on it and therefore could be scratched easily by dragging a product across it, or flour might fall on the glass window down below. Instead, you would have a side window which was not going to be scratched because you weren't scanning against it, and flour would not fall onto the side window. So having a side scanner was thought to be an ergonomic improvement, and European check stands first spearheaded the movement for trying to come up with an idea of a side scanner to do that. And Frank Nickl spent a great deal of time trying to understand the ergonomic requirements in Europe in order to meet that demand for a more ergonomic scanner. Separate from that, in the U.S., there were many industries that were finding that faster is not better and therefore could cause some sorts of injuries, including, I have an article here saying that musicians are suffering repetitive stresses also, including a violin player, because of an awkward hand motion of having to hold the violin could cause cumulative stress injuries on playing just the violin. And this was going on in many other industries, including the meatpacking industry, where they do a lot of cutting of meat in cold environments, could cause stresses in wrists, etc. So out of all of that, Food Market Institute came up with an ergonomic task force to try and understand some of these issues. This is an example of some of the information that came out of there, describing some of the issues of how to improve ergonomics, including understanding various check stand designs and what are the advantages and disadvantages of different check stand designs ergonomically, whether it causes back problems or neck problems. So in the development of Sabre Scanner, which was the first side scanner that Frank Nickl worked on, he had the bottom portion of the scanning area, a relatively smooth area, so that the product could be slid directly across the product area. Later also a scale platter could also be put there. And then the side window was then not hit, or it would not cause it to have trouble reading because it was covered with dust or something like that. Another thought was that in scanning products such as a can of beans, you would scan it in front of a side window. It's a natural position since most of the barcodes on, say, cans are on the sides of the cans. So in scanning products, it was thought to be a more neutral hand position. So in the United States, more work was done on testing various scanner designs to try and decide what scanners would have ergonomic advantages. In the FMI testing that was done, the side scanner, namely a Sabre scanner, came through as being better than many of the other products that were done. So Frank Nickl was successful in coming up with a design that did improve it. This is an example of some of the data that was taken out of the ergonomic task force. And in the data, it shows I believe it was the Sabre scanner, which was actually tested. It shows this BV line here is below the low risk area for scanning. Mm-hmm. So you can see that he not only attempted to come up with an ergonomic design for both the European market and for the US market that would improve the ergonomics and lower stress on the human body, he was successful.